Hi, here is the schematic diagram of a separator. So if you look at this separator, so we have one inlet and two outlet. The first one is a feed suspension where the feed will come into the separator, and then we do have two outlet. The bottom one is the solid plus with some liquid, and the top one is liquid plus some solid. So why we do have liquid plus some solid, and why we have solid some liquid? Can we get 100% solid or 100% liquid? So the answer is no, because the solid liquid expression is never complete. So there might be a certain percentage that will be in the separator, and there is the percentage of liquid in the precipitate. So we need to agree with this theory. So some fine solid living in the overflow of filtrate stream, and some liquid will enter with the bulk of the solid living through the underflow gate. So it will be not 100% solid or 100% liquid. So there will be a certain percentage of liquid in precipitate, and it was a certain percentage of a solid in liquid solution. So here is the concept of solid liquid separation, where the separation of the solid is usually expressed as mass recovery, and then the separation of the liquid is usually characterized by the moisture contents of the cake or concentration of solids in the underflow. Besides, the separation efficiency of the solids and the liquid are best considered separately because different applications place different emphasis on these two. For example, in thickening, the emphasis is on the high efficiency for the liquid, while for in a computer or compression, high efficiency for the solids is required. So here is a few concepts of solid liquid extraction. And next we go to the predeterminant of suspension. If we go back to this process, so it is better if we have a pre-treatment of suspension first. So in order for us to have a high recovery in the later stage. So for the pre-treatment of suspension, why we need to apply this concept, because it can enhance either chemical or thermal pre-treatment can enhance the dispersion process for later stage. Besides, more series and pump of a widely varied nature can benefit from pre-treatment, whether dispersion by sedimentation or by flotation, and a conditioning effect can be obtained using several processes such as coagulation, flocculation, addition of inert filter airs, crystallization, freezing, temperature or pH adjustment, thermal treatment, and aging. So we will see the effect of a few of this process. For example, we will see coagulation, flocculation, and in our next slide. So here is a method or a process that we do have for the treatment of suspension. We have coagulation, flocculation, and colloidal destabilization. So what is coagulation? Coagulation is we are using it to destabilize of colloid by addition of chemical that neutralize the negative charge. So as we know, if we do have a negative charge, we want to neutralize it, what we need to do is we will introduce the positive charge particle. So we have a coagulant agent. We have we do have aluminum. Aluminum we have positive 3. The charge is positive 3. We have iron positive 3, and we do have a more charge molecule. So, and then what is flocculation? Flocculation is the agglomeration of destabilization particle into a large size particle known as floc. So what we do, we have a small particle. So what we need to do is we need to combine these all small particle, and we combine it, and it will become a bigger particle or large size particle. So we call it floc. And then this floc can be effectively removed because it becomes a large particle, so we can get it easily. Then we go to colloidal destabilization. What is colloidal destabilization? Destabilization by charge neutralization. So we will introduce a positively charged ion. So it will neutralize the colloidal negative charge and destabilize them. And then the colloid will aggregate by itself and start to settle. So next we will see each of this method. So for example, concept of coagulation. I said earlier, coagulation is a chemical process because we introduce a chemical. So the objective is to destabilize of colloid by addition of to destabilize the colloid by addition of chemical that neutralize the negative charge. So we have negative charge in our solution. Now we will introduce the positive charge, the chemical that contain positive charge, and then it will neutralize. So the chemical will known as a coagulant, usually quite ionic. So what is quite ionic? Quite ionic is chemical that contain the positive charge. So for example, we do have impurities here. We add the coagulant. So what we did is the coagulant we trap the impurities like this. We trap the impurities and then we will settle down and make it precipitate. So we have a precipitate here at the bottom. So here is how it works. So now we have this impurity that has a negative charge. As we know, once we have a positive charge, so here it will fill at the outer layer of the impurities or negative charge. And then when we add positive charge or the coagulant, it will give strongly absorbing species of opposite charge. So, and we will neutralize particle with no double layer. So this is how it works. So here is a good method. Is the method that we can consider. Method that we can consider in solid liquid extraction. Coagulant 8. Here is the other substance that we can use as a coagulant, as a clay mineral, silicate, or polymer. So this coagulant, we are using it just to aid the coagulation process. Besides, for polymer, if you are using polymer is also reinforced flux. So next we go to flocculation. Here is flocculation. What is flocculation? Flocculation is the agglomeration of destabilized particle into a large size particle known as floc, which can be effectively removed by sedimentation or flotation. So what is floculation? As I said earlier, concept is easy. We have a small particle. We try to combine it and make it bigger. Flocculation can cause the destabilize or discharge collide to cluster. This compound consists of long carbon chains with active groups such as amine, nitrogen, or sulfate along the chain. So we would like to promote agglomeration of particle into larger flock. So you can refer to this link to the matter what is the flow calculation. So here is the function 8. The chain is long enough to allow active group to bond to multiple the covalent. So what you do is, for example, we have it. It will try it and all these small particles. We try to we try to what we call it to make a bond between all of this small particle, and then it will make a larger particle. Now, if we do have here is one of the example. So we can you imagine if we have a lot of these structures, so that's why we can get a big particle or larger particle. So here is the diagram of what we call it a flow calculation. Here is flock formation with the polymer. Here we got a flock formation with polymer. So what I do is we add the polymer. Here we have a small particle. What it do is to will destabilize the it will destabilize this particle, and then what happens next is the destabilized particle will aggregate. Wire coagulation and wire flocculation. So here is a few factors that can be considered or affect the method. Either we want to use coagulation or we want to use flocculation. It's because it depend on mostly it can depend on the size. We can say that it is affected by the gravity if the size is big, or can the gravity can handle the size. We can use either coagulation and flocculation depend on the factor that we considered before. So for colloid, we will use colloid once the particle is so small and gravity settling is not possible. So for colloid interaction, for example, as we know, for colloid interaction, there is two forces acting on the colloid. Either it's electrostatic expulsion or intercolloid or van der Waals attraction. So it will be for electrostatic expulsion, for example, here, once we do have a negative charge here, what it will repel with each other. So all of the particle it will have a kind of a magnetic characteristic where it will repel each other because negative and negative charge. So if we do have a magnet, negative and negative, what we will do, it will repel with each other. So certainly it's not possible. And then we look at the charge reduction coagulant. So what we need to do is we need to reduce the charge. So what we need to do is we need to put coagulant. We use the coagulant to reduce the associated repulsive charges. So once we introduce the coagulant, so it will reduce the repulsive force. And then here is another link for the colloidal interaction. You can refer to it and you can understand better what is about colloidal interaction.